off with a video talking about why are mineral resources considered non-renewable. So we're talking about mines today and mining practices. So to intro, we have this.
In medieval times, alchemists tried to achieve the seemingly impossible. They wanted to transform lowly lead into gleaming gold. History portrays these people as aged eccentrics, but if only they'd known that their dreams were actually achievable. Indeed, today we can manufacture gold on Earth, thanks to modern inventions that those medieval alchemists missed by a few centuries. But to understand how this precious metal became embedded in our planet to start with, we have to gaze upwards at the stars. Gold is extraterrestrial. Instead of arising from the planet's rocky crust, it was actually cooked up in space and is present on Earth because of cataclysmic stellar explosions called supernovae. Stars are mostly made up of hydrogen, the simplest and lightest element. The enormous gravitational pressure of so much material compresses and triggers nuclear fusion in the star's core. This process releases energy from the hydrogen, making the star shine. Over many millions of years, fusion transforms hydrogen into heavier elements, helium, carbon, and oxygen, burning subsequent elements faster and faster to reach iron and nickel. However, at that point, nuclear fusion no longer releases enough energy, and the pressure from the core peters out. The outer layers collapse into the center, and bouncing back from this sudden injection of energy, the star explodes, forming a supernova. The extreme pressure of a collapsing star is so high that subatomic protons and electrons are forced together in the core, forming neutrons. Neutrons have no repelling electric charge, so they're easily captured by the iron group elements. Multiple neutron captures enable the formation of heavier elements that a star under normal circumstances can't form, from silver to gold, past lead, and on to uranium. In extreme contrast to the million-year transformation of hydrogen to helium, the creation of the heaviest elements in a supernova takes place in only seconds. But what becomes of the gold after the explosion? The expanding supernova shockwave propels its elemental debris through the interstellar medium, triggering a swirling dance of gas and dust that condenses into new stars and planets. Earth's gold was likely delivered this way before being kneaded into veins by geothermal activity. Billions of years later, we now extract this precious product by mining it, an expensive process that's compounded by gold's rarity. In fact, all of the gold that we've mined in history could be piled into just 3 Olympic-sized swimming pools, although this represents a lot of mass because gold is about 20 times denser than water. So, can we produce more of this coveted commodity? Actually, yes. Using particle accelerators, we can mimic the complex nuclear reactions that create gold in stars. But these machines can only construct gold atom by atom, so it would take almost the age of the universe to produce 1 gram, at a cost vastly exceeding the current value of gold. So that's not a very good solution. But if we were to reach a hypothetical point where we've mined all of the Earth's buried gold, there are other places we can look. The ocean holds an estimated 20 million tons of dissolved gold, but at extremely minuscule concentrations, making its recovery too costly at present. Perhaps one day we'll see gold rushes to tap the mineral wealth of the other planets of our solar system. And who knows, maybe some future supernova will occur close enough to shower us with its treasure, and hopefully not eradicate all life on Earth in the process.
And there's always that hope, right? More gold without actually dying. So, in your own words, after watching this video, why would we say that our mineral resources are non-renewable? So this question is going to Jackson.
Gold only comes from like a supernova event or a star. It's pretty rare.
Yeah, absolutely right. Pretty rare. And that's kind of has to happen before the Earth is created, you know, so that we don't get destroyed as living things on a planet. And so all the stuff we're mining is considered non-renewable. So going along with that, almost all Earth's materials are used by humans for something. So we're going to talk about the different things that we mine. Because when we talk about mining, most of the time people think mining has to do with metal, which it does. We do mine a crap ton of metal, and that's the scientific measurement of it. But other things that we do mine as humans, number one, fossil fuels for energy. So all of the fossil fuels that we get are actually mined. So you drill for oil, you extract gas and petroleum that way as well. So that is considered mining. Number two is metals for making machines. So metals for cars and for buildings and for your phones and for batteries and for literally anything that has metal came from some kind of mine. Something that you probably don't think about as something you mine are gravel. So we mine gravel for making roads and buildings. So Point of the Mountain, that mine over there, it is considered a mine. We'll talk about the different types of mines. So Point of the Mountain is considered a mine, and we actually mine sand and gravel from there for other things. Another one, so sand for making computer chips. So another thing we get from Point of the Mountain is sand. So we make computer chips from sand. We also mine limestone and gypsum for making concrete. Concrete is actually one of the most one of the biggest CO2 producers when it comes to the creation of it. We put a lot of CO2 into the atmosphere by trying to make concrete, and part of that comes from mining the gypsum and the limestone for that. After that, we have clays for making ceramics. So any kind of ceramics we make, that comes from mining. And then last but not least, what you actually think of for mining, gold, silver, copper, aluminum for making electronic circuits. So each of these things as well are going to be mined in different ways. So not every single thing is mined like Snow White and the Seven Dwarfs, where they have their pickaxes and they're in the mine and they're singing along, which is not as fun as real mining, or is more fun than real mining, I guess I should say. My family one time, we went to this place called Ely, Nevada for a family vacation. Mostly it happened because my in-laws took us somewhere during spring break. My mom's like, oh, I need to take my family somewhere during fall break, you know, like competing in-laws and parents and stuff. It's so fun. So we went to Ely, Nevada, which is like the middle of nowhere, Podunk, Nevada. It's like on the border. But we went there because she wanted to see the night sky. But Ely, Nevada also has a garnet mine. There's this place called Garnet Hill. And garnet is the January birthstone, if you don't know. It kind of looks like this. I literally thought that I was going to go up there and I was going to like open up these rocks and hit them with hammers, and there'd be this beautifully formed garnet inside of all these rocks, and it was going to be awesome. It was not. It sucked. Garnet is really fragile, and so when you like broke open rocks with hammers, you'd like break the garnet inside of it, and then it was just like little shards. So yeah, mining takes a lot of skill. It's not as easy as you think it is, and it is definitely not fun at all. So the different types of mining, we have surface mining and we have underground mining. So surface mining is exactly what you think it would be. It's mining at the surface. So used to extract ore from closer to the surface of the earth. This is one of the most common mining methods. So more often than not, when we're doing mining, we are mining at the surface. We're not digging below, which most people, when they think of mining, they think about like going into those like actual mines, you know? Like if you ever played Donkey Kong, they have like the Minecart Carnage one where you're like going through mines on the little mining carts. More often than not, that's not how mining works. So the different types of mining that are surface mining, number one is an open pit mine. So Utah actually has the largest open pit mine in the whole entire world. And that is what? Kennecott, yeah. Kennecott Copper Mine. Kennecott Copper Mine is the largest open pit mine in the whole entire world. You can see it from space. So, you know, that's pretty cool. We also had the largest mine collapse in the world, and no one got hurt in it. So, huzzah for Kennecott. Dredging is a type of mining that actually happens in water. So just like the video showed how there's a lot of dissolved gold in the ocean, dredging is getting minerals from water by like floating it to the surface. Next we have strip mining, which is what this is. This really fast GIF or GIF or whatever you want to call it. You just take strips of the land and you pile it on. So you just kind of remove the little parts of the land at a time. And then last we have mountaintop removal, which is what Point of the Mountain is. We are literally digging away the mountaintop to get our soil and our sand and our gravel. So the other type of mining removal is underground. So this is used to extract ore from below the surface of the earth, and it's used when the mineral ore is deep, the mineral ore is of high quality, or to reduce the environmental footprint. So when we did our cookie mining last time, how many people's cookies were like completely destroyed? Like whose cookie like either got broken in half or there was like a bajillion crumbs? So when you're doing surface mining, you're gonna have more of an environmental impact just because you are taking apart the environment. So you are like, well, first of all, you have to remove all of the trees from the area, and then you have to remove all the plants, and then you start digging it up, and you just kind of ruin the whole environment. So some people will actually do underground mining. They'll use different techniques in order to save the look of the environment. It's not always the most healthy thing for the environment, but like the actual environment itself, so like the trees, the animals, all the things together, is a little bit more intact. So before we move on, when you're on your guys' picture that you drew on your table, I want you to tell me or write down what type of mine did you actually draw. Did you draw a surface mine? Did you draw an underground mine? If it was a surface mine, what kind of mine did you draw? As their example, raise your hand if you did a surface mine. Okay, out of our surface mines, who did an open pit like Kennecott? Leave your hand up. How many of you did strip mining? Leave your hand up. How many did a mountaintop removal? Leave your hand up. Okay, cool. For the rest of you guys, you all did underground mining. So, did you do like more of a classic mine, like big hole in the ground or big hole inside the mountain? Yeah. All right, so when we're talking about mining too, there's two other kind of practices that don't really fit into either of these two categories. So placer mining and in situ leaching. So placer mining is like the gold rush. So people came, there was gold in the stream, and gold is more dense than rocks. And so they take a little pan and they fill it up with stuff and they just kind of let the water come in and carry the rocks out, and then at the very end all you have left is gold. Just for funsies, I'm curious, has anybody in here ever done panning for gold before? Okay, I'm glad I'm not the only weird one. We went on, well, my family, when we went on vacations, we always drive places. And so one year we drove to North Dakota, and on the side of the road it said like panning for gold, and I was like, stop everybody, we gotta do this. And so I think I was 13 at the time, and made my whole entire family stop so I could pan for gold on the side of the road. I have a vial of gold now, so you know, definitely was worth my time. So placer mining is an ancient method of using water to recover heavy minerals using a difference in density. Like I said, gold is very, very dense. Like the video said, it is a lot more dense than water, and it's a lot more dense than rocks. And so you can kind of float the other rocks. I know floating rocks sounds like a really stupid thing to say, but you can move the other rocks using water because they are less dense than the gold. In situ leaching is, if you're going to put it in a type of mining, it would be an underground mine, but it's kind of different because you're not actually like mining it out. You're injecting acidic or basic solutions to liquefy all of the ore and then slurp it out like a smoothie. So the idea is that you know where the ore is, so you drill down to the ore, you inject this stuff that can dissolve the ore you want, and then you pump it back out to the surface. And so after that happens, it goes to a processing plant, and the processing plant takes out the ore that you actually want. So when we're doing our drilling down method, so we haven't talked about underground mines yet. So when we're doing underground mines, you can either do the classic mine or you can drill down like to get oil or natural gas. So you can either do a conventional well, which just goes straight down into the ground, or you can do an unconventional horizontal well where you drill down and then you tap into the oil or the gas-rich shale. So when we're doing underground mining and it's a drilling method, number one, more often than not, you do a conventional well. So a conventional well is where you just drill down into a pocket of oil or gas or whatever you're trying to extract from the ground. So this happens more often than not for our fossil fuels. You just drill straight down into it, and then you pump out what you want, and then you're done. But sometimes what you're trying to get out is trapped in some kind of like rock. So this is going to sound a lot like in situ leaching, but it's not in one specific way. So when we come down here, we're not pumping anything into the ground. We're just pumping into this rock, and we're breaking the rock up to release any of the oil or the gas that we're trying to get out of it. So in situ leaching is different than unconventional horizontal wells, because in situ leaching you're actually pumping things into the ground, whereas with unconventional horizontal wells, you're just breaking the rock up to release the material that's already there. All right, so at your tables now, I want somebody to choose one of these four different topics. So someone's going to choose surface mining, someone's going to choose underground mining, someone's going to choose in situ leaching, and someone's going to choose drilling. And I want you guys to describe the differences of all of those mining methods. So figure out who's doing what, and discuss at your tables. does smell like a bush. Yeah, it smells like recycled paper, like the type of like brownish paper that you might have. Yeah. I was thinking to like smell like mildew or something. I was like, because my gross is very different as a parent to your guys' gross sound like blood. Alright, so I'm going to draw a name. Whoever's name I draw, you're going to describe to me whatever mine you talked about. So, this one is going to Dylan. What mine did you talk about?
I talked about the situ leaching.
Perfect, in situ leaching.
Put something into the ground to break something down and then just suck it up.
Perfect. So in situ leaching, you pump something acidic or basic into the ground to dissolve the ore you're looking for, and then you suck it back up and you pump it to or you ship it to a refining factory. Wow, I can talk. All right, this next one is going to Avery. Avery, what kind of mine did you talk about? Surface mining. Okay, fill us in. Perfect. So easier minerals that are close to the surface. We do a surface mining. And like you said, we have strip mining, mountaintop removal, open pit, and dredging. Okay. Let's see. Carter, did you have a different one besides in situ leaching and surface mining?
I did drilling.
Perfect. Let's hear it.
There's two different types of drilling methods. You can drill straight down and release the horizontal well. You can just extract resources.
Perfect. So more often than not, you're using the conventional well where you just go down and you bring up the materials you're looking for. Sometimes the material is a little bit harder or it's trapped in a rock. You'll use the horizontal where you'll break up the rock and just take the stuff from it. All right, let's see if the sticks are really good at finding who did the last type. Jake, did you happen to do...
I did surface.
Dang it. Okay, let's see. Will, what type of mining did you do? Where are you sitting, Will?
Which one?
You. Oh, the Mill's not here.
I did the underground.
Yes! Okay, tell us about underground mining.
With mining underground, it usually more expensive minerals.
Perfect. So the minerals are either really worth it, so it makes sense to go underground, or they're just deeper ones, or they're more hardy, and so it's easier to remove them that way. So to kind of talk about mining, we're going to watch this video. So eyes up here. I'm going to ask some questions from the video, so make sure you're paying attention.
I know it looks bad, it looks like a big hole in the earth, but what you can't see is what we're gonna do. I've been a miner all my life. It's my profession and I take it seriously, and I think my dad always taught me to be stewards of the land, and as you take something away, whether it's you make your business in a town, you give back to the town. If you have a relationship with people, you give back to the people. Well, it goes the same with our earth. We take the gold out, and we need to put it back. So he's always instilled that in me. Good miners, as they mine, they always have the end product in mind. Reclamation's expensive. Every responsible miner who does reclamation, there's always an issue between spending money that doesn't recover any costs. Basically, this does nothing but cost us money. It doesn't do anything for the bottom line. But it's the right thing to do. We pulled gold out of here, and this has provided a living for us. And now it's time to put something out. This topsoil has everything in it to grow. It's got all the seeds, all the spores. It's got very rich compost. So this is a little bit above and beyond what we're required to do, and we're just going the extra mile. And we've kind of discovered what works around here, so the most important critical thing we can do is put the topsoil back on. So you can see how fast things grow. If you look over there, you can just start to see green. And that was actually in 3 months. 3 months ago, we removed it from its natural state, put it up there, and it's already growing. It looks bad now, but in 3 years, you will never know that we mine here. They start with an end in mind. So when we started this our end goal was to reclaim this site. So we mined it according to that plan, knowing that we're gonna reclaim it. So yeah, it's true and dear to my heart is the reclamation. So I'm glad to share it with you guys, and hopefully we can see this in about 3 years. It'd be nice to come back, take some pictures, and see what it looks like.
All right, cool. So we talked about reclamation last time when we were doing our cookie mining, right? We talked about reclamation and bringing the cookie back to its, well, as close as you could to its normal state. So he said something about reclamation. Why is reclamation something that's really hard to do? All right, so here, Gage. So why is reclamation something that a lot of miners maybe don't like to do, or it's something hard for them to do? So does reclamation help them get any more gold or stuff? No, right? Perfect. So they're covering everything back up. It is just costing them money. So reclamation just costs the miners money, and so more often than not, they don't like to do it. But he said that it was really important for them just to make sure the land was back to where it was. He said something important about the type of soil he was putting on top of the mine. So what did he say about the type of soil he was putting back together? So this question is going to go to Charlotte. Perfect. So he's putting topsoil there. So if we're talking about our soil horizons, the topsoil is it was what letter? What letter represents our topsoil? If you remember back to your soil horizons, this question is going to Anthony. So our topsoil, what letter did we use to describe it? It was O, yeah, exactly, it was O, yeah. So that's organic matter. So when you do your surface mining, a lot of time you're moving the topsoil off, and so you're moving off all that organic matter. So if they were just to kind of cover it up with the soil they already had, nothing really would grow there because there's no organic matter. It wouldn't actually work. So talking about succession, we're going to kind of dive back into last unit. What type of succession are we going to be seeing from this mine? Are we going to see primary succession or secondary succession? This question is going to Jay. So, perfect. This is secondary succession because we already have our soil there and we are going to have things start growing from that. So what would we expect to see growing first on top of this mine during reclamation? So thinking about succession again, what types of plants or how many plants would we expect to see start growing? And this question is going to Kaden. So what kind of plants would we expect to see start growing first during secondary succession?
Like small plants.
Perfect. So like small plants, grasses, and then eventually we're going to go to shrubs and trees, and then we're going to get to our climax community. So succession really has a lot of different parts of it, and it's really important to be aware of like what things go back into success and go back into reclamation. So some negative impacts from mining, and the reason that we're talking about reclamation is mining is really important. It's actually essential. We cannot live our lives that we live right now without mining. But sometimes the air quality, the surface water quality, the groundwater quality, soils, vegetation, and the aesthetics, so just how an area looks, can be changed by mining. So all of these things are byproducts of mining, and so we have to be aware of them. More often than not, the one that is the biggest problem is the water. That surface water and groundwater quality can actually go down. A lot of old mining operations, so like during the gold rush where people would come and they would get their gold and all this stuff, they would use different chemicals to help get the gold and to purify the gold, and they're ghost towns now. They're ghost towns because there's no point in being there because all the gold is gone, but also because of the quality of the water that was left behind. It's not really suitable for people to be living there. And so because of that, towns get deserted. So all of the things that mines produce, all of the wastes have different names. So we have gangue, slag, and tailings. So tailings are usually your like solid stuff that's left over. So like leftover minerals, leftover metals, things that you don't use. Like if you're mining copper, you actually have to go through and like process the copper. So you're gonna have leftover like byproducts of getting the copper. Slag is usually the chemicals. So this is usually the chemical stuff that's left over, and gangue is usually the liquid. But gangue, slag, and tailings are all things that are left over after mining operations. And acid mine drainage can create toxic conditions in runoff. So again, to purify or to extract metals, you're going to be using acids or bases to help purify, like get rid of the rock, get rid of any kind of byproduct you don't want. And that stuff, when you mix it with water, has a tendency to go wherever the crop it wants. And so a lot of individuals, a lot of mining companies aren't quite as precise with controlling their byproducts as other companies are. So if you're done writing this in your notes, I want you to label gangue, slag, or tailing somewhere on your mining diagram on your table. So, just some information about tailings. You don't need to write this down if you don't want to, but it's just the byproduct of mining. That's what tailings are. So, metal mining companies dump about 220 million tons of toxic mine waste into water bodies every year. So, we're talking about the byproducts of mining, and they're usually dumped into bodies of water. So why is mine waste toxic? It's because naturally occurring elements in crushed rock become toxic when exposed during mining. So in rocks, we have like arsenic, lead, and mercury that are nicely packaged away and are not going to hurt us. But when we go through mining, we break those rocks down, those metals and those elements are exposed, and they can get in the waterway. And then other things that can affect the waterway are additives like petroleum, sulfuric acid, cyanide, things like that. So how does that affect us? Why do we really care if it gets in the waterways? Well, number one, it affects the marine life. So we're going to be breaking down the ecosystem in the water. Rivers, wetlands, and forests, they get clogged with this mining stuff. And we've talked about how we have our ecosystem services. And so if we start breaking down the ecosystems, those ecosystem services are going to start not working, and we're going to have to do something to fix them. And on top of that, all of that waste can get into our food. So it can get into our drinking water, it can get into our livestock, and it can get into our produce. So the 7 hottest places for dumping tailings are in Alaska, which is not great, the Canadian lakes, in Chile, Norwegian fjords, Turkey in the Black Sea, Indonesia, and Papua New Guinea. So 4 mining projects across the world account for 91% of the waste dumped into water bodies each year. And those ones are the ones in Indonesia, Papua New Guinea, Batu Hijau in Indonesia, and another one in Papua New Guinea. But if you look at who dumps into natural bodies of water, we have 2 different United States ones. United States run mines that dump into the water. We have 2 Canadian, we have 3 Canadian, 3 Australian, Indonesia, and Papua New Guinea. So not very many mines are doing this, but they're very large mines that are doing it, and so it's causing a big problem. So we're going to talk more about sustainable mining and what that looks like and what things can be changed to make these mines a little bit more friendly to the environment.
What happens to a mine after it is closed? When talking about mining operations, one might think of images like the ones shown in James Cameron's movie Avatar. While deforestation and topsoil removal is part of the mining process, it is not the permanent landscape that mining leaves behind. In fact, many mining companies around the world are legally obligated to engage in a process called reclamation. which is restoring the landscape to its original condition. Reclamation of mining landscape includes resloping of hills to their natural shape before mining commenced, placing down topsoil, planting native vegetation that previously grew in the region, and continued water quality tracking long after the mine closes. Let's take a look at some real-life examples of reclamation. In this picture, you can see that the landscape is deforested and most of the topsoil is removed. In the next picture, you can see the trees that are planted after mine closure, and the soil is replaced to sustain the tree's growth. The reclamation process also includes detailed planning of the closure topography to ensure the reclaimed land is integrated with the surrounding ecosystem. All old mining landscapes are transformed to benefit future human use, whether that be to improve the safety of the environment or to make it suitable for urban or community use. The Six Flags Amusement Park and La Cantera Shopping Center from San Antonio, Texas, USA, was once a portion of the Beckman Quarry mine. The Beckman Quarry still continues mining today, and students are allowed to tour this mine. The world-renowned Butchart Gardens in Victoria, BC, Canada, was once a limestone quarry mine as well. The Butchart Garden covers an area of 55 acres and receives more than 1 million visitors each year. Mining companies often invest significant resources to ensure the reclamation is completed properly according to legislation. And it is a process that takes place progressively throughout a mine's life. The mines that you see on TV and films are not always what the end landscape of mining is like. If you want to learn more about mining and the environment, subscribe to our future videos.
Oh, there those do. So, some practices for sustainable mining. Number one is we're going to reduce. So we're going to try our best to reduce waste that remains around. So we're going to try to figure out a way to use less materials when we're doing our mining. We're going to figure out ways to take the stuff, the byproducts of the mine, and have it be less. Talking about the byproducts, sometimes they will take the byproducts and they will also use them to create other materials. So maybe they're mining for copper, but they have a byproduct that is lead. So rather than just letting that lead be all over, they're going to take that lead, they're going to filter it, and they're going to try and get other valuable materials out of it. So they're not just leaving this extra stuff around that could be potentially hazardous. We're going to take it, we're going to form it into something, and we're going to make it useful. Another thing we can do is stockpile or store for future use. So if we are getting stuff from the mine that we're not using currently, we can take those things and we can stockpile them and use them for the future. Downcycle, so use for low purpose. So if we are doing mountaintop removal and we're trying to get sand, maybe we're getting some gravel out of it, rather than leaving that gravel there, we're like, oh, we can use that for the roads. And then remediate after all uses have been considered. So that's going to be your reclamation. So there's a lot of different things that mines are trying to do to make sure they're more sustainable and that they leave a smaller footprint from the ecosystem. And then we're not going to watch this because it is crazy long. But if you want to go over mining, Mr. Anderson has a great video for you to watch. So what I'd love you to do right now is